are live back to CCT Central Time. Yeah, baby. Okay, hope you like the new theme song. Shout out to the Tonight Show. I think this is the new Tonight Show, wouldn't you say?
Nah, I wouldn't say quite. I would say more of it is an ASMR kind of deal, if you know what I'm talking about.
Emily Siegel!
Hey guys, how's it going? Back to you again. This is Casual Code Doc, episode number 3, is it already?
Oh no, we're at 4, baby.
4, I am sorry.
Alright, and this is an unscripted, unedited, one-cut video.
It's unedited. This guy is putting in no work into these videos. Am I gonna
Actually, I am. Today we're going to be going over some binary search and a variation of it that is a lot trickier to think of. So, without further ado, I'd like to get to our first segment, a new segment to the show called the Word of the Day with Sandy.
Just laughing in the background if you don't hear that already, folks.
Sandy, say hello.
Louder.
You gotta be louder. All right, Sandy, can we get the word of the day?
The word of today is ablution. A washing of the hands and face or bathing of the entire body. I begin each day with my morning ablution.
Excellent. And that concludes the first segment of the show. Talk to you later, Sandy.
Okay.
All right, now time for the real show to get started. Binary search.
Binary search. Now, I remember binary back in the day as, just the 0101, the 2-digit system as opposed to our decimal
That's the
system.
binary system. This is a binary
search. Now,
There's
Josh,
nothing to
why
do
is
with
it
that.
called a binary search then?
That is a good question.
It doesn't have anything to do with the binary system. It would seem like it has to go with like 1 or 2. It's like a 2 system.
Well, my thoughts on that is the binary search is able to eliminate half of the options every time.
Each time, that's right. I remember that.
So that is in logarithmic time. All right, so let's take a look at this coding question. We got
nice.
Search insert position. So this is a bit different than regular binary search. So it's basically just
Emily,
looking.
Is it my turn?
That's Sandy. It's looking for the target in the vector nums. But usually in binary search, if you can't find it, you just return -1. Here they want us to return where it should be. Okay. So to do binary search, we're going to have int first. Actually, I like calling it low. So the lower end gets 0, and int high gets the nums.size -1. I'm going to start off by writing off binary search. And if I can't find it, I'm just going to return -1 and then modify this. So we're going to have while. So binary search is like while low is less than high, we're going to continue this. And then we have a mid. And mid is going to get low plus high minus low divided by 2. Now, Emily, if I may ask you a question. How do you find the average of 2 numbers?
That's very simple, John.
Yes.
Excuse me, Josh. You add up all the numbers and divide by the number of numbers you added up.
So why am I not finding the middle value by doing low plus high divided by 2? Why am I doing low plus high minus low divided by 2? They are equivalent, actually, aren't they?
No.
They actually are.
The median is not equivalent.
This is not the median.
You said the middle number.
Oh, same thing. Like.
No, it's not.
Well, what I'm trying to say is the middle. If you have something at the first index and the seventh index or something, then like the third index is the middle, like 3.
Yeah.
3 is the average of those two. The halfway point. Halfway point,
So the
average.
median.
No, it's the mean, but since everything's incremented by 1, I can use the word middle to represent mean also. Just think of the middle. How do I find the middle between a high and a low point? How do I find the middle between 2 points? How do I find the middle between point 1 and 10?
I guess you find the median. The mean.
The mean. Okay.
I guess if they're in chronological order, yeah.
Yes, these are just indexes. So the reason these two... No, they're not. Okay. These two are actually equivalent. So why did I write it like this? All right, we're back. And
was that a suspenseful ending, wasn't it?
yeah,
Why
and
did I
it
write like
is
this?
because let's say we have two really large numbers, low and high are like really close to int max, and we sum them. And we sum them, and
Sorry,
then their sum is greater than int max, then we have an overflow, and then we are donezo. That is not good. We do not want it to be possible to have an overflow. So what we're first going to do is subtract them, then divide by 2. Their subtraction is definitely going to be less than int max.
Josh, when Mom comes home, could you help her with the cat litter?
Mm-hmm. Okay. So then we have mid is there. Okay, so we calculate the mid each time. And then if nums at I is less than our target, what do you guys think that means? So the number, let's say we get to 3, is less than 5. We should make the low one get mid plus 1. Else, if nums I is greater than the target, then what we're going to do is the tall one, the higher one, is going to get the mid minus 1, because we want it to go to the left of it. Then else, if it's equal, that means we actually found it, so we can return the mid, which is the index. Now, what we're going to do here is if it ever gets to here, if low goes past high, that would only be because if the number does not exist in the vector. So what we're going to return is return -1. Now this is binary search. However, we have to be a little more careful, and this part actually it took me a while to understand. I'm not going to lie, even though this was an easy question. So maybe you think, let's just return the lower end. Maybe you think low and high are always equal to each other. So let's think about that. Okay, let's get an example going. This one here. Low and high, so we're searching, let's say, for 5, and so the middle value is going to be 3. It's less than the target, so then the low is going to go up here, and the high is still up here, then 5 equals it. Okay, wait. So actually, if it's in there, it's definitely gonna work, because it's just gonna return the mid. However, let's say it's 4. We're looking for 4, and 4 is not in here. So the mid starts off at 3. Then low is going to jump up to 5. And then 6 is still the high. So then the mid is going to be 5, because the mid in between 5 and 6 is going to be the lower one, down to 5.
Emily?
And so 5 is already greater than our target of 4, so that means high is going to get mid minus 1. You see how it just got past it? That's a problem. So we're returning low. Actually, not quite. Not quite low. We would be, so low is always going to be, so, how do I explain this? So, let's say we were searching for 6. Let's see what happens. So in that instance, when we were searching for 4, we did want to return the low. But let's say we're searching for 6 here. So then mid is here, greater than that, so low goes up here, then high is here, then the mid goes to 5, and 5 is still less than it, so low is going to move up here. That is still not a good case. I have to think of the case where it's actually... Wait, so then low is going to go here, and then high is going to go here. I know it's not low. Let me run this. Actually, let me see what the what an edge case would be that would break this. Line 9. If nums at I is not declared in the scope rate. If nums at mid no, not that. Yeah, these off by 1 errors are really tricky. I think this is... Wow, did I like just lose Wi-Fi here or something? Okay, let's see what comes up here. Okay, here is edge case. Here we go. We're inserting 2. 2 is, a mid's going to be here. This is greater than the target, so then high comes down here. Okay. So high already equals now the same thing as low, so it's going to come down here and return low. So it's going to be putting the 2 in here. That is not what we want. We want to put it here. So basically what we're going to be doing is if nums at low is greater than the target, actually is less than the target. If it's less than the target, then we're going to return low plus 1, and then otherwise we're going to return low. Notice how it can't actually be equal to it because it would have been returned here. Alright, let's see if this works. I think it should be faster than that. I'm pretty sure I did this exact thing and I got 4 milliseconds at another time. Okay, whatever. So I just want to recap what's happening here, why this is true. So our mid thing is, I'm going to write this out. So our mid is, if it's even, okay, if mid is even, if size is even, vector, mid goes to the lower index. Mid is always going to the lower index because this divided by 2 is always going to truncate the stuff. So it always goes to the lower one. And like for example, the mid here would be 3, not 5. Because 0, index 0 plus index 3 divided by 2 is 1, not 2, not 1.5, not 2. It's just 1. So it's here. And so since it's a lower bound thing, you can think of it like high. If like this is your middle, for example, and it's greater than it, high is going to be 0 and index 0, which is the mid index minus 1. So it's going to get negative 1. And we just don't want that to be possible. And it's impossible for low to get to negative 1. It's only going to go from 0 to the end. So if size is even, mid goes to the lower index. We should use the lower because it starts at 0 and has the ability to go to size. Like you could actually insert it after here too. Does it ever go past? No. We could probably do a similar thing with high and then just add one also. Yeah, I don't know. This part is still kind of confusing. Alright, well, hope you enjoyed this episode of CCT. I'll play you out. I'm already going to YouTube. See ya!